So everybody, thank you for being here. It's a huge pleasure to talk about persistence layer, how to make it ultra fast. Of course, I will cover the theory because the practice that I can cover, I will cover today later. Okay. So today, let's talk more about the persistence layer, why it's important, how to handle that, and especially how to take advantage, especially in our code, in our architecture, in our application, and so on. Before start, one thing that I usually like to explain in talk is why do we need database anyway? So why we care about database? And going to history and philosophy because those are area that I enjoy a lot. We do have database because we need to handle information. We need to make sure that information endure the knowledge through the whole humankind. Okay, the humanity needs knowledge. The humanity needs information, and convert that information through wizard and knowledge as well. So the main goal is information, is knowledge, and that's go through humanity. And yes, we can say that the database, the first one that we got, was not super modern. It was because we wrote in temples and caves and libraries and so on. And with the time, we need to have more uh, we need to have more advanced skills, advanced techniques, especially because at the beginning we only have caves, but we wrote a little bit of information. We just had a small piece of information. With the time, we start to write more and more often, in more knowledge, in more types. So caves was not enough, especially because cave is limited, is not safe, of course. Sometimes you might face some wild animal, so some data corruption must be a rock that's broken and things like that. And based on that, we start to move in to and think more about how to order this knowledge in a more sophisticated way. As a consequence, we got libraries. Libraries was one good way to handle the information because right now we can put information in books and put these books in categories. It is way easier than caves, of course. However, uh, we got an issue because right now we write a lot. Thus, is not enough. I also need to go physically to this place. And of course, it's require time. So right now, what I need to do is to distribute that information somehow. That's why we do have a database, distributed database. Okay, and getting out the philosophy and the history and start to talk more about software engineering. Why do our modern application need data storage? It's because it's where the state is. It is where the current opportunity is. And especially, it is where the new opportunities are. Okay, Otavio, what do we mean about the new opportunity, the current opportunity and new opportunities? I do have a sample, super cool, around the finance area who had a bank, okay? And this bank had a card as a product, and then it start to analyze information, read information, and collect this log. And then they could see that a lot of clients of this card, this credit card, bought a lot of wines. As consequence of that data, they took a decision to create a winery. And based on that, uh, this winery was the biggest winery in the whole South America for 3 or 4 months. Can you believe that based on data, we were capable to create a new product, and based on that, a bank start to sell wine? Can you imagine that? Because the card was the current opportunity, and based on that data, it will create new opportunities. Okay, um, data is super important. Hopefully, you got the idea how amazing and how important the data is today. But even with that importance of data, we still have a lot of issues and battles to handle with data. And when you talk about state of affairs and compare application with the persistence layer, we can see that at the application layer, we do have several maturity models. Probably you know the glory of REST as one of the maturity models. We do have several paradigms with SQL database. We have SQL, NoSQL, several types of NoSQL that we cover a little bit. And of course, several database flavors, because even with the same types, eventually those databases have particular behavior. Okay, for example, Elasticsearch and MongoDB, those are document types, but even that, those have different particular behavior. For example, Elasticsearch has a super advanced search engine, and MongoDB has several geolocalization engine to make easier to do things. Okay, so it's on you to define which one is better on your scenario. Here is a report of this year of Stack Overflow, where you can see that we do have several SQL database, but the number of NoSQL database is increasing more. So we do have MongoDB, we do have Redis, Elasticsearch, DynamoDB, CosmDB, BigQuery, Cassandra, and so on. So the idea to use and explore more NoSQL database and SQL database and combine them are increasing, especially because right now we are facing several complexity inside this database. And beyond this choice that we need to do on the architectural perspective, we also need to think more about the challenge at the beginning and the maturity of the application, especially on the persistence layer. Why? Because usually when you handle with modeling of the database, normalization, we need to start doing that. And at that point is where we don't have enough knowledge of the business. The business is not mature enough. We don't have knowledge enough about the business. So the chance of change and do anything around that is super high. And the refactoring in the database is a huge challenge, because when you compare application with database, applications about refactoring and IDE, especially because application is stateless. There is no state there. But when you go to database, and on the other hand, we need to run migrations. We need to run several points to make sure that the information does not break. And we need to make sure the server is up, even during migration. And going that, we also need to handle with migration and upgrade of database. That is a challenge by itself, right? I mean, right now, when you do a migration between Java 11 to Java 21, is a huge nightmare, libraries and things like that. But again, it is stateless. If something goes wrong, we can return. We can do a git revert and return everything to original. But we're not able to do that with state application like database. And of course, evolutionary data, migration, refactoring, and so on, upgrades. So this kind of thing have a huge lack of knowledge. We don't have enough information, even that we know that's super important. And as any kind of perspective inside architecture, the The persistence layer is under a software attachment decision. That means we still need to face the two laws of software architecture. Everything in software architecture is trade-off. So if I go to one way, I have good points and bad points. And the why, the reason is more important than how. It doesn't matter if you're going to use SQL, NoSQL, or any kind of NoSQL. I need to understand first why I'm doing that. And we know the software architecture, we know the rules, and how to achieve success inside our application. Of course, in exploring software architecture, I usually resume that in 3 points. Of course, there are more, but the goal today is to explain more around persistence layer. So I will talk briefly about the 3 points. So business, achieve the business, impact the business. Isolation, make sure that your business is not impacted by technology. What do I mean about that? For example, when I run my application, I should not know that I'm using Cassandra. I should not throw an exception showing Cassandra exception. I should handle that more friendly, more user friendly. And of course, performance. Once you took the decision, let's take advantage of that decision. Based on that, so I know that the why is more important than how. Everything has a trade-off. On the persistence layer, we need to pay attention on the philosophy of polyglot persistence. What does that mean? So when we talk about a person who is able to speak several languages, a polyglot is one person that's capable to use the best language to the best approach. For example, if I speak Spanish, when I go to Argentina, I can speak Spanish instead of English. If I go to Italy, I can speak Italian instead of English. So if I go to German, I can speak Germany, I can speak German instead of speaking English. So I have more approachable way because I know several tools. And it also happened with the database. So if I know those database, I can use the best one that fits in better on my scenario. Remember, the why is more important than the how. Okay, so if I can achieve that with SQL, or if I can achieve that with NoSQL, SQL, Graph, and so on, that is fine. Of course, I'm assuming that you know SQL database, so I will cover more NoSQL database. There are much more. I just put here 4, so wide column, graph, document, and key value. However, there are time series, there are multimodal, there are vertex database, and so on. I will explain briefly all of those. For example, key value, where the structure is giving a key, I will return the value. So it looks like a map in Java. Then I do, oops, no, wrong. I do have the user case, for example, using Redis. So caching, session management, real-time analytics, and pub subbing. Then I do have several recommendations. Why I do that, especially because when I talk about NoSQL database, the biggest mistake that I saw and I faced was try to use NoSQL, iSQL in modeling. Thus, people still try to do normalization in NoSQL database. And of course, different database, different approach. What you can do with Redis, you can simplify schemas, you can identify key patterns, you can explore the idea of key value as cache, as batch operation. Remember, in Redis, the majority of the time, the information is on memory, and then go to a snapshot. So it's faster to read and write. And of course, one thing that you should not do, avoid complex joins, especially because there is no join. So you need to do it on the application layer, not on the database layer. Be aware of over normalization. There is no normalization, as I said, and there are databases that shows index, but my recommendation is avoid that. Here is a sample of distributed Redis. As you can see, I do have my key, and the structure here is key master slave or follow or master replica or primary replica. The idea here is I have one to write, another one to read, where I do sharding. So give a key, I generate a hash, and based on that hash, I have masters who is in charge of that hash. For example, if Otavio is a key and generate a hash where the value is 1, I go to the master A. If I generate Grady Augustus and the hash will be 6,000, it will go to master B and so on. So I will charging the information through the hash, through the key. And when I write, go to the master. When I read, go to the replica. Then I do have one more, that's white column. So I have my row key. So it's pretty similar to key value, where I have my key, I have my value. The difference here it is that right now I took the information small piece that I call columns. So instead of have a huge blob value like I do have in the hash map, I can put small piece of informations in columns. As you can see here, I do have Apollo as a key and then columns like dirty, color, and so on. Here are samples of user case with white column, for example, Cassandra, where I do have the O'Reilly retail, social media analytics, real-time analytics, login and monitoring, and so on. So here are the case of do and don'ts. As I mentioned, the normalize is your best friend. Remember, when talk about Cassandra and white column in general, we are most of the time talking about create queries ready for read, because the write is cheaper than read. So duplicate when it makes sense, and then make it ready for read. As don't, you can use secondary index. So in general, with Cassandra, you can retrieve information only by the key, but you can have the secondary index. But usually use that with moderation. The normalization is your best friend. However, remember, normalization means duplicated information, and you to update each point that you duplicated eventually. Here's a sample of distributed Cassandra. As you can see here, what we do have is the master's approach, where I have my key. The key will generate a hash. The hash will took any instance, because any instance is in charge to read or write. And this instance server node will coordinate the request and then return to the client. Move on to the third one, where I do have my document structure. I do have my document DB. As you can see, it looks like XML or JSON file. And move on to explain more. I do have, for example, MongoDB. As you can see, those are samples where I can use and explore MongoDB. For example, content management, catalog management, mobile application, and social media platform. When you compare with the previous ones, so key value and white column, this one is more powerful or more flexible to read, because I can read more easier another fields than the key. Okay, so I can do almost the same thing that I do have with relational database, if without big deal. The power of DocumentDB, on my perspective, and document in general, is because I can create embedded documents. So I can create documents inside documents. For example, here I do have my document Diana. where I have the name, Diana, Dirty, our array, and then a subdocument that is symbols. And then symbols, I do have another object. So subdocuments is like that. You can use more index. You can normalize when it makes sense. But remember, it's in the logical, it's not in the database size, it's not in the database layer or tier. It is on the application layer and tier. So pay attention that we need to handle that manually. Of course, as don't, you can use embedded documents, but avoid to have like 3 GB of embedded documents, break more. Avoid over-index, and beware that one document, if it becomes huge, it'd be hard to read and write and do anything like that. This is a sample of MongoDB. As you can see, it's a distributed one. I do have the schema of the primary and replica, where I do have one to read to write and the read by the replicas one. As MongoDB, I also can do the sharding. So I have the read and write, I have my sharding rules in charge for the index. And that is the idea. So I have my key, I generate the hash, and based on that hash, I go to the shard, a specific one. Move on to the next one, where I do have graph database. So just to remember what we saw about NoSQL types, we saw key value. That is a map where I have the key and the value. I mentioned the wide column or column family, where I have my column, the ID, and then my value, it is on small piece that we call columns, and document that has the structure of JSON or XML file, where I can do search more complex or have more flexibility to query something else than the ID. Right now, we're gonna go and gonna see the graph, where I have my entity, I have my relationship, and this relationship has an object to hold that information. So I can inform the direction of the relationship. I can inform the properties of these relationships. So on this case, I do have Apollo, Ares, and Kratos, and I have the direction. So Kratos was killed by Apollo. Apollo was killed by Kratos. So think about recommendation engine. Just because I know one people from famous, it does not mean that these people knows me. So the graph feeds in points like that. Those are simple of do and don't. So embrace relationship-driven design. Understand that you have such a powerful resource on relationship here. Again, directions and properties inside the direction or inside the relationship. Explore labels, explore index, but you can do any kind of join, but that's not the high point. And pay attention to don't overcomplicate the graph design. So if you're transversal, it's super complex. It'll be super complex to navigate, so you take more time to read and do queries on that graph. Here are some samples of Neo4j. So social network, recommendation engine, knowledge graph, fraud detection, network analysis. Here we do have Neo4j as distributed solution. As you can see, I do have leaders and followers. And to right, I have the same idea and structure, so you can pay attention to it. And when talk about trade-offs, of course, you know, or supposed to know SQL very well. But when you talk about NoSQL database, we need to understand, again, the power of trade-offs beyond, of course, the basics like the CAP theorems and so on. So we need to understand that with key value, I might have the highest scalability. So they usually are by memory, are super fast to read and write. However, the flexibility to read that information is pretty low. What does that mean? I I'm capable to read information only by the ID. Remember the ID of the map. So if I don't have anything else in the key, I'm not capable to read information. And as much I go to the flexibility, like for example, the graph, I can do queries, I can do aggregate. However, I can do relationships, the joins. I can be more advanced doing direction of these relationships. I can have properties on that relationships. I might not have super scalability like I do have with key value. So I have more flexibility. I have more power of queries, but it's not super scale like I do have with key value. Is one thing that you should pay attention. Okay, I mentioned why I mentioned why database are super critical to us. I mentioned the power of the persistence layer inside our application. But I forget to mention something, right? I mean, it's impossible to talk about persistence layer if we don't talk about my application. And if you ask me, what's the best picture to show to represent the communication between application database on my side, at least on my perspective, it is one here right now, because it's basically two heroes, two group of heroes, super important, super criticals, and those are fighting against each other. They are not able to understand each other because we do have several lacks and we do have several issues with those heroes, right? And why I mention that? Because usually when I go to application, I do have my paradigms. And when I go to my database, I do have another paradigms. So for example, here, I have my application where I using Java, I'm gonna use object-oriented language, for example, Java. As you can see here, I have a person, I have address, I have a relationship where my person has a list of address. So I'm talking about pointers, I'm talking about information memory, but of course, my relation database does not provide any kind of pointers. So what I need to do instead, I need to create a third table to have this link, to have this reference between those tables. So I have my person, I have my address, and then I have my link between one and another one. And that is the big deal. And that's why we're still living in a civil war against each other. So, for example, the huge challenge right now for us is that communication, because that communication is a big deal. Why? Let's explore Java, for example, but you can use any language that you wish. Java, we can have arrays, you can have polymorphisms, we can have encapsulation, and of course, types. And on the other hand, the huge amount of database, they don't understand that. They don't speak that. And we need to translate that information. Because usually when we talk about the database, we do have normalization, we do have denormalizations, and of course, a different structure that we do have with application. And that's in that distance that we call the mismatch mapping, because we need to have a bridge between application database and that has a huge cost of power consuming. That's why, for example, I love the idea of exploring EclipseStore. So if you are not familiar with EclipseStore, it is a good opportunity to go and learn more about it. So let's share the link. But anyway, you can go to EclipseStore. And the idea of EclipseStore is to reduce the number of layers between your application and your database. So that's why, for example, as you can see, it is super fast with EclipseStore than the JPA. So I do have two samples here, one with EclipseStore, as you can see, is basically Java, and another one with JPA that I need to do this conversion between Java and in my database. And based on that, I have the time to convert the translation, reflections, and a huge process around that. With EclipseStore, I don't need it. So that's why they usually go 1,000 times faster than relational database. So it's worth to check more information about it. So that's the layer, the simplest structure with EclipseStore. As you can see, I have my business logic, I have my microstring, and that is it. I don't need to do the translation that I usually do with another database solution. Okay, so usually two different paradigms, database, application, different types, and they don't talk each other. To reduce this cognitive load, we have patterns. Hopefully, everybody did this mistake before. So the goal here of the patterns is avoid to do the same mistake twice. And right now, I will only cover the 6, especially because we are talking about 50 minutes, 45 minutes of presentation. But the idea here is to cover some integration between Java and application, and of course, the trade-off. Why I mentioned the trade-off? Okay, Jonathan, that's a good question. How EclipseStore and Jock is compared? EclipseStore is a database itself. Okay, so you don't need anything else. You can put some layers on the top if you wish, but it's a database itself. The Jock will work with a relational database. I will cover right now Jock. We can compare Jock with the driver because it's going to use the database structure. And eventually, when we talk about database structure, sometimes we are far from the business or far from the domain of the application of entities. So we need to do the conversion. And then we're going to face, again, the mismatch in patterns. So just to cover a little bit here, the 6 patterns, so driver, data mapper, DAO, active record repository, and DTO. And remember, when talk about persistence layer and patterns, we have the distance. So I might be closer to the database, so I will explore more the data-oriented programming. If I go closer to the application, I will go closer to the object-oriented programming. It's up to you which one you're gonna use, okay? So if you go close to the database, you're gonna explore more the principle of data-oriented programming. So we're gonna have separating code from data. So the goal here is the data, not the behavior. We're gonna represent this data with generic data structure. I will treat the data as immutable. And of course, I will separating the data schema from the data representation. When I go to another extreme point, I'm gonna do the opposite. So I will expose the behavior to high data. I will explore the abstraction and explore more the polymorphism on that thing. Here, it starts to explain more the patterns. Start from the close to the database and then go to the close to the application. I do have the driver mapper or the driver communication layer where it explores more the immutability of the data. In the sample here, I'm using simple JDBC, as you can see. So I do the connection, I'm doing query by person table, and I'm returning this information by my result set. And of course, this result set is immutable by convention. Going next on our patterns, the good point of the driver on the communication layer, I have more flexibility on the database perspective. However, I'm super far if I'm exploring DDD with object-oriented. And on the other hand, to simplify that, one thing that I can do, if I wish, is mapper, that I will create a layer to abstract that conversion. I can do it manually, like Spring JDBC template, or I can do automatically use a notation like JPA and things like that. So you can choose. On those scenarios, I should use the person, the same query that I did. So one, I need to put a notation, everything going to be automatically. Another one, give the result set, I need to convert by my bare hand. So driver, close to the database, communication layer. Mapper, responsible only to translate database and entity. Then I do have one layer to centralize all data operations. That is my data access object, or DAO. So right now I do have one more abstraction to represent this database operation. So one to update, delete, insert, and so on. The good points: I centralize data operation. I centralize the conversion and communications. The bad point or the cons is, of course, the impedance mismatch between my database and my application. I also have the active record, of course, because for some reason I can give higher power on my entity. So I have my person, and this person can persist itself, can list more person, can do database operation and so on. It is good because I have huge power, but with huge power comes responsibility. So it's break the solids, because right now my person is doing a lot of things. So is a person and also the database connection. And go super far from the database, we do have the repository that is a super abstraction layer. So you might know from Jakarta Data, Spring Data, and Quarkus and so on. So I have my entity, I have a couple of notations, and basically I do have my personal repository. As you can see, I do have the save method, and this save method will, for example, do a operation. So what does that mean? It is an insert, or it is an update. The implementation will cover that for you. So I do a find by ID, but as you can see, I have no idea where or each implementation I'm using. So each database I'm using based on that repository, because I'm just doing a save, I'm doing find by ID, I'm doing some queries by domain-centric way instead of doing some technology aspect. And again, as we usually talk, we are facing trade-off everywhere. So of course, you can go to the data and be more data-centric. However, your client, you'll be a little bit fat because you need to do the conversion when it needs, you need to centralize the operation, you need to do everything by your bare hand. And on the other hand, you can have more layers to do more abstractions. For example, here, given that I have a repository, this repository you do centralized data access operation. The data access object need to do the mapper or the conversion, and of course my database, the communication. And every time I talk about layers, please pay attention, because layer can help and also can give you a huge nightmare. So my time is over right now, but the idea here is to explain how powerful is the persistence layer. Is a huge amount of options, a huge amount of flavors you can choose, understand. Of course, it's impossible to cover everything in 45 minutes, but there is much more, like persistence configuration, data store, cache, connection pool, data manipulation, frameworks, style frameworks, and so on. So it is just a brief idea. And of course, if you want to know more, Karina Varela and I wrote a book where we cover that best practice for Java application. That is all for today. Please let me know if you do have questions. And thank you for being here. And please follow me on Twitter, LinkedIn, Instagram, so everything, YouTube as well, everything as Otavio Java.